Hello everyone. On this video we will be looking at different types of triangles and the Pythagorean theorem. Okay, so the first type of triangle we're going to look at is the equilateral triangle. Okay, so the equilateral triangle, if you look at the word equal, that's in it. Well, the spelling of the word is a little different, but equal is in it, so you know all three sides are the same length and all three angles are exactly the same. Okay, now doesn't matter what length the sides are. This could be, each side is a length of 7, each side is a length of 12, each side is a length of 50. It doesn't matter. But you do have to remember that for an equilateral triangle, all of the angles have to be 60 degrees because for a triangle, all of the angles have to add up to 180 degrees. Okay? And if it's an equilateral triangle, the only way all three angles can add up to 180 degrees is if they're all 60 degrees. 60, 60, 60. All right. Now, for an isosceles triangle, two of the sides are equal instead of all three. And at least two of the angles are equal. Okay, so in this case, you have these two sides are a length of 15, and this side is a length of 17. These two angles are 70 degrees, and this angle is 40 degrees. All right, and last, well not last, but next, is a scalene triangle. And a scalene triangle has no equal sides. They could be anything. It could be 3, 5, 6, 7, 8, 9, 3, 4, 5. It doesn't matter. It's just none of the sides are equal. All right. So if you're still writing, feel free to press pause, but we're going to go ahead and move on to our next page. Where our next triangle is a right triangle. Now, right triangle has a 90-degree angle. Okay. Now, the two sides that connect the right angle are called legs. So you have the first leg, the second leg. It doesn't matter if you call this leg A, leg B, or leg B and leg A. They're both just the legs of a right triangle. Now, the side that's opposite the right angle is called the hypotenuse. Okay. Now that's important that you know that it's the opposite because it's not always drawn like this. Sometimes it's drawn like this. Sometimes it's drawn like this, where this is the right triangle. Okay, so you always know that the side opposite is your hypotenuse, no matter how it's drawn. This side is opposite the right triangle, right angle. So this is your hypotenuse. Okay. Now, it is possible for a triangle to be more than one type. So let's look at these two examples. You have a right triangle that is also a scalene triangle. Okay, so it's a right triangle because it has a right angle, but all the sides are different lengths. Okay, so if you have also this triangle where two of the sides are the same, oh, forgot a little, but it's also a right triangle. So it's an isosceles triangle and a right triangle at the same time. Okay, so it is possible for a triangle to be more than one. All right. Now next is the acute triangle, where you have no angles that are larger than 90 degrees. Well, they're not 90 degrees at all. They're all below 90 degrees. Okay, so you can have a triangle with, again, 60, 60, 60. So you know that it's not only an equilateral triangle, it's an acute triangle. Because if all of the angles are 60 degrees, none of the angles are larger than 90 degrees, so it's also an acute triangle. I mean, an equilateral triangle. So once again, a triangle can fall into more than one category, as long as you understand what each category means. Okay. Now, if you have an obtuse triangle, that's where you have an angle that's larger than 90 degrees. Okay. Now remember, a 90 degree, I'm just going to put my protractor on top of here for a second. Okay. Now, if you have a triangle that's 90 degrees, then remember it's going to go from here and it's going to go up to the 90 degree mark. So it's going to look something like that if it were 90 degrees. Okay, so I'll just kind of tap it in there. Okay, so that will be your 90 degrees. So here we see that the angle goes past the 90 degrees. And usually you can just visualize it and tell if it's obtuse or if it's acute. The same way you could with an angle that's greater than 90 degrees or less than 90 degrees. All right. Okay, so if you are still writing this, feel free to press pause. But we're going to go ahead and move on to our next page. And that's where we get into the Pythagorean Theorem. Now remember, the Pythagorean Theorem could only be used for right triangles. You can't use it for acute triangles or obtuse triangles or any other shape. It can only be used for right triangles. Okay, that's a very, very, very common mistake where someone will see just a regular triangle and try to solve for the missing side using the Pythagorean Theorem, and it comes out wrong because it's not a right triangle. So remember, it can only be used on a right triangle. Okay, so let's take a look at our right triangle. Again, you have leg B and leg A, or you can make it leg A and leg B. It doesn't matter which A or B you make the legs. Because of the formula, it's going to give you the exact same answer. As long as you remember that your hypotenuse is always opposite the 90 degree angle. Okay, so if you have leg A, you're going to square it plus leg B squared. Like I said, that's why it doesn't matter, because it'd be the same if you had leg B squared plus leg A squared. It'll give you the same answer on this side, equals the hypotenuse squared. Okay, so you usually see it as A squared plus B squared equals C squared, or sometimes instead of A and B, they'll use X, Y, and Z. Or it can be X squared plus Y squared equals Z squared. Okay, both of those represent the same thing, and is your Pythagorean theorem. Okay, now let's say if you wanted to solve for a particular leg, or you want to solve for your hypotenuse. If you have A squared plus B squared equals C squared, I'll write this out. A squared plus B squared equals C squared. Say you wanted to solve for C, you would just square root both sides. So the square root of C squared is just C. And that's going to equal A squared plus B squared. So that's how we get this one. Okay. What if you wanted to A squared plus B squared equals C squared? What if you wanted to solve for side B? Well, you'd want to get the B squared by itself by subtracting A squared from both sides. So you have B squared equals C squared minus A squared. And again, if you square root both sides, square root of B squared is just B. So B equals the square root of C squared minus A squared. The same thing if you wanted to solve for side A. If you start off with your A squared plus B squared equals C squared, if you want to solve for side A, you subtract B squared from both sides. So you have A squared equals C squared minus B squared. Then you square root both sides. The square root of A squared is just A. So A is equal to the square root of C squared minus B squared. Okay, so that's how you would find either or any of the missing sides. All right. So if you are still writing this, feel free to pause it But we're going to go ahead and move on to our first example. Okay, so what if we wanted to find the missing side? So for question A, this is side A. This side has a length of 48, and this side has a length of 50. So you can tell these are both right triangles, so we know we're going to use the Pythagorean theorem. Okay, so starting off, a squared plus b squared equals c squared. Okay, we see here, like, remember the two sides connected by the right angle are your leg A and leg B, or leg X and leg Y, whichever variable you want to use. Okay, so we're solving for side A, so we're going to subtract b squared from both sides and then square root both sides. So you have A equals the square root of c squared minus b squared. All right, so we see here, this is your B, and your hypotenuse is your C. So A will equal the square root of c squared, so that's 50 squared, minus b squared, so minus 48 squared. Okay, so remember, the squares are only canceled out by the square root if there is just a single term, or if it's just multiplication. Okay, so because you have two terms, and you can always tell a term by the plus or minus sign. If you have a plus or minus sign, it's more than one term. So because you have two terms, you can't just cancel the square root and the square. So here you just have to go and simplify what's inside. So 50 squared is 2,500 minus 48 squared, which is 2,304. And this gives you the square root of 196. Okay, so 2,500 times 2,304 is 196, and the square root of 196 is 14. All right, so for problem B, what I want you to do is press pause and solve problem B on your own. All right, so I'm assuming you've paused it and you're already done, so let's go ahead and verify. Okay, so we're solving for the hypotenuse, which is your C or your Z, depending on which formula you want to use. So x squared plus y squared equals z squared. So if we square root both sides, we know that z squared, or z, will equal the square root of x squared plus y squared. Okay, so your z is going to equal the square root. Your x is 24, so you can make that 24 squared. Plus your y is 45, so that would be 45 squared. Okay, and that's going to equal 24 squared, is just 24 times 24. That's 576, plus 45 squared is just 45 times 45. It's 2,025. So that gives you the square root of 2,601, which is 51. Okay, so your side Z is 51. All right, so if you are still writing, by all means, feel free to press pause and finish up. But we're going to go ahead and move on to our next example. Excuse me. Okay, so what is the distance between centers of two pulleys if one is placed 9 inches to the left and 6 inches above the other? Okay, now remember, we're using the Pythagorean theorem, so drawing a picture will probably be the best way to approach that. Always seems to help, well, not always, but probably 95% of the time, drawing a picture of a story problem will help you visualize it. Okay, so I want you to press pause and try to solve this one on your own. All right, so I'm assuming you've paused it and you've tried this one. So let's go ahead and verify your answer. Okay, so first thing you have is you have the distance between the centers of two pulleys. Okay, so if you have your first pulley, okay, so we'll have the pulley here and we'll call that pulley number 1. Now, the other pulley is placed 9 inches to the left and 6 inches above the other. So 6 inches above. Okay, so this is pulley number 2. And they want to find the distance between those two pulleys. So in other words, they want to find the distance between the centers of these two pulleys. Okay, so we'll name that Z, or you can name it C, whichever one you want to. I'll call it C. Okay, so we want to know what this distance is between pulley number 1 and pulley number 2. Okay, so we know that a squared plus b squared equals c squared. And if we square root both sides, this c equals the square root of a squared plus b squared. Okay, now you can write it this way, or you can write it c squared equals a squared plus b squared. I just have a thing about my variable being on the left. That's my little hang up. So if you want to write it this way or this way, you're good either way. Okay, so side A, or you can make this side A or this side A, it doesn't matter. You're going to get the same answer. So you have 6 squared plus 9 squared. Or you can make it 9 squared plus 6 squared. That's why it doesn't matter which one you use first. That's going to equal the square root. 6 squared is 36. Plus 9 squared is 81. Just 9 times 9 and 6 times 6. That's going to equal the square root of 117. Now that's not a perfect square, so you're not going to just get the square root of 117 and have a nice, neat whole number. So you're going to have to plug this into your calculator, and you will get approximately 10.8 inches. Okay, and that's if they ask you to round it to the nearest 10. Okay, but they will always, well, not always, sometimes they mess up, but they will usually tell you to round it to the nearest tenth, the nearest whole number, the nearest hundredths, or whatever the case may be. Okay, just so happens in this one, we just rounded it. So we could have put C equals the square root of 117, or we could just put approximately 10.8 inches. All right, so hopefully this made sense to you, and I'll see you on the next video.